This is part 6 in a series of videos showing how to create and use methods in OmniView. In previous videos I've shown how to create these two methods here, and I've shown how to copy them over to another channel. So I've had these methods online and running overnight, and they're producing numbers. We can take a quick look at the answer screen and we can see the results. Overnight we can see the answers that have been produced by each of these methods. And you can see my analyzer in my office here doesn't have an air conditioner, so the fluctuations you see, they're not very big, very small fluctuations, but they vary with temperatures. These methods are producing answers for us. But you may ask, what good is it if the only thing I can do is look at them in this answer screen? Ideally, what you want is OmniView to communicate these values out to the plant DCS, perhaps being watched in a control room, by a process manager. How do you get these numbers, these values, out to an interested party? Well, the way you do that is by using input-output. So if you go out to the analyzer and click on the I/O Devices tab, I have defined a couple of I/O devices that I am simulating. I don't have a real DCS here, but I have a couple things here which act like a DCS system. How to create these will be shown in another video. So let's just for now assume that I have these and that they are running and they are awaiting data from OmniView. The way to get started is, again, you have to have the lock, the OmniView lock, and we're going to bring up the I/O map. The I/O map is a way to connect data values being produced by OmniView to the outside world through a device. So let's say we want to write one of these methods out to a Modbus DCS. This is a digital DCS device. So we'll select it and it brings up the entire map. These are all the potential things that can be mapped to a DCS device. What we're interested in are methods. So we're going to select this filter, and what we're interested in is getting the value, the number being produced by this method out. So that would be a floating point number, which is written as an analog value, and it is an output. I have this filter here. Let's turn this filter off. You can see that there's a whole bunch of potential values that can be written out, but we do want to restrict ourselves to, for an example, to channel 8. And you see there are two methods that we have on that channel that are currently running and producing numbers. You could restrict ourselves just to that method there. So let's map this predicted value to the Modbus DCS. So you select that row, and then down here at the bottom you have to provide a couple of values. First one is it's essentially the type of the value that you're going to write out. It's going to be a floating point number. This determines what kind of Modbus address is going to be used. Next, we assign an address. Now, we have kind of an unconventional numbering scheme with Modbus here. This 71,000 series address, it really gets mapped to a proper Modbus address. So I'm going to select this address, 71025. Now there's a couple other things here we don't need to provide. Tag names are used for inputs, so we're not going to assign a value there. This method is producing a single numeric result, so we do not need to specify an answer name. The engineering units, depending on the type of device that you are mapping this to, these may be important. We're mapping this to a digital system. We'll do an analog system next, But for a digital system, the engineering units are not needed. So really all you need are the block and the address. So let's save our changes. Notice more columns have been filled in the table. There's the block and address. Here's the value being written out. So this is the value. If we were to go look on the answer screen, that would you would expect to see this number in the chart or the table. And since this is a digital system, we don't scale the value. So these two numbers, they're the same number. The rounding's a little different. The final columns out here show you the time that we wrote that value out and whether it was successful or not. OmniView writes these values out on a recurring basis. I think it's every 5 seconds. We go out and look up the latest value for this method and we write it out. It's important to remember that if the method gets taken offline and is not producing numbers anymore, what you'll see is this number will not change. The last value will be written out over and over again. So to prove that we are indeed writing this number out, I'm going to bring up a program. We use a program called Modbus View, TCP, which is simply a little Modbus program that it just reads and writes Modbus addresses all day long. All right, to see our number, I have to do a couple things here. I need to go to holding registers and I need to go to the right address. Our address that we use in OmniView is 71025, but we subtract 70,000 from that, so the address is really 1025. One final thing here, I have to tell it how I want to look at this number. Do need to be talking to unit 1. There's our number. It's in scientific notation, but that does translate to the value that we see here. So we have successfully mapped the output of an OmniView method out to a DCS. In the next video, I'll show you how to do this for an Opto 22 input-output device.